Hi friends, welcome back. So, in this video, we are going to discuss about the addition of rationals and irrationals. So, consider this expression 2 root 3 plus 3 root 2. This expression is multiplied by another expression 4 root 3 plus 5 root 2. So, how can we do this? Let us consider this one as first term and second term and third term and fourth term. So we multiply these two, we add these two and we add these two, and totally we add the sum, the two sums. So 2 root 3 plus 4 root 3, 2 root 3 plus 4 root 3. It is 2 plus 4, 6 root 3, and it is 3 root 2 plus 5 root 2. It is 8 root 2. It is the answer. Subtraction is also same. Instead of plus, we will do minus, and we will add both the sums, which is 2 minus 4 is minus 2 root 3 plus 3 minus 5 minus 2 root 2. And it's the same case in the multiplication too. Instead of plus or minus, we do multiplication, but the small trick is we multiply this root 3 and root 3, which becomes 3. So 2 4s are 8, 8 3s are 24, 24 plus 3 5s are 15, 2 into root 2 root 2, 15 2 is 30, total is 54. And it's the same in division too. 2 root 3 by 4 root 3 cancel out 1 by 2, and 3 root 2 plus 5 root 2, these 2 cancel out, and 1 by 2 plus 3 by 5. We can use the regular LCM method and solve. So, now we are going to solve the exercise 1.5. So, the first question they are asking us is we should classify the following as rational or irrational. So, one thing is, if we add irrationals to any rational number, then it is always irrational. If we subtract, then it's irrational, and if we multiply, in some cases it becomes rational and sometimes it doesn't. It's in the same case of division too. Sometimes it becomes rational, sometimes it doesn't. So, first one, 2 minus root 5. As I already told you, this is irrational because I have told you that if we add or subtract irrationals with a rational, then it is irrational. So, second one, 3 plus root 23 minus root 23. So, tell me, is it rational or irrational? Many of us think that this root 23 and root 23 get cancelled and it's rational. No, it is not. See, this whole thing is irrational, and this single thing is also irrational, and everything becomes irrational. Simple. This is the small mistake we all do. So, the third one, 2 root 7 by 3 root 7. Sorry, 7 root 7. So, this 7 root 7 gets cancelled and it becomes 2 by 7, which is rational. Simple. And this one, 1 by root 2. I have already told you that in some cases division of irrational with a rational gives rational, but sometimes it doesn't. In this case, it doesn't. So it is irrational. And the fifth one is 2 pi. Now guess this one. Is 2 pi rational or irrational? Many of us say that it's irrational. No, it's irrational. Because pi is irrational. You might be wondering that pi value is 22/7, which is rational. But I have already told in the previous video that 22/7 is an approximate value because it is denoted as circumference by diameter, whereas circumference is the approximate value because we measure it with a thread or something. It doesn't go the exact value. So pi is irrational. So 2 times pi is an irrational number. This is one of the cases in which an irrational number doesn't become an rational number in the case of multiplication. So the second one is we should simplify the following expressions. So you could try. Okay, the first one is 3 plus root 3, 3 plus root 3, 3 plus root 3 multiplied by 2 plus root 2. Yes? Yeah. So we can write 3 as root 9 plus root 3. Yes, root 9 is equal to 3. And 2 we can write as root 4. Whereas root 4 is 2 and nothing changes in root 2. So we can use the identity root a plus root b into root c plus root d, which is equal to root ac plus root ad plus root bc plus root bd. So what is a? Root of ac. 9 3 are 27. So root of a into c, 9 into 3, 27 plus ad. So 9 4s are 36. So root 36 plus ad. 9 2s are 18 plus bc. This is b and this is c. So root 12 and bd. 3 2s are 6 plus root 6. So is there any further simplification? Yes. This becomes 6 and this becomes root of 9 into 2 and plus 6 into 3 into 4 plus this is as this root 6. So 6 plus root of 9 into root 2. So remember the identity root of ab is equal to root a into root b. So root 9 into root 2, which is 3 root 2. And this becomes 2 root 3 because root 3 into root 4 is 2, so 2 root 3 and plus root 6. And this is the simplified form of this expression. Simple. Now the next one. Three plus root 3 multiplied by 3 minus root 3. So how can we do this? So remember the identity a plus root b into a minus root b, which is a square minus b. We can use a plus b into a minus b identity, and a square minus b square. A square is a square and b square is b, as this is root b. So a square minus b. So what is a square? 3. 3 square minus what is b? Root 3. So b. Instead of root 3, we will write b, which is 3. Simple. Nine minus 3 is equal to 6. Simple. Completed. So the next one is by using identity root a plus root b whole square, which can be proved by using a plus b whole square. And so root 5 plus root 2 whole square. So a plus b whole square is equal to a square plus 2ab plus b square, where root a plus root b whole square is equal to a plus 2 root ab plus b. So what is a? 5 and b 2 plus 2 multiplied by root 10, which is 7 plus 2 root 10. Completed. Simple. So the next one is the final one. So root 5 minus 2, root 5 minus 2, root 5 minus root 2 multiplied by root 5 plus root 2. So we will use root a plus root b multiplied by root a minus root b identity, which is equal to a minus b. So what is a? 5. What is b? 2. Answer 3. That's all. So friends, that's all for this video, and the next video we will solve the remaining problems in this exercise. Thank you.